Let us understand the meaning of the term buoyant force by performing simple experiments. Push a cork down into water taken in a trough. What do you observe? The cork rises up and comes up to the surface as soon as we release it. Now, to keep it beneath the surface of water, we have to exert a downward force. This means that the cork is experiencing an upward force. The upward force is due to the force exerted by the water. The downward force which we exert counters the upward force. This shows that when a body is partly or wholly immersed in a fluid, the fluid exerts an upward force on the body. The upward force experienced by a body when partially or wholly immersed in a fluid is called upthrust or buoyant force. The phenomenon responsible for this upthrust is called buoyancy. Let us perform a simple experiment to prove this. Suspend a body from the hook of a spring balance. Observe the reading. Now slowly immerse the object into a trough containing water. What do you observe? We observe that the spring balance is indicating a less weight as compared to the initial reading. Now slowly remove the object from the trough. We observe that the spring balance reading is slowly increasing. This shows that any object partially or wholly immersed in water or any fluid experiences an upward force called buoyant force, and this force is responsible for the apparent loss of weight of the body immersed in it.
This is the water density chart, and this is how you will find the density of the water to make your measurements accurate. We got a reading of 30 degrees Celsius in our tank today, so we'll look across and find that the density of the water is 0.9957.
That's interesting. 1 cubic centimeter of water has a mass of 1 gram. This is not a coincidence. If you research the history of the metric system, you will find that the first standard metric unit of mass, the gram, was defined as the mass of 1 cubic centimeter of water. The spectacle unfolding behind me here is a graphic demonstration of buoyant force. Amazingly, the buoyant force acting on a hot air balloon is able to lift a basket filled with passengers. This powerful force appears whenever an object is immersed in a fluid. Do you know what fluid this hot air balloon is immersed in? Remember that both liquids and gases are fluids. The fluid surrounding the balloon is air. Let's investigate the buoyant force in another fluid, water. This is a concrete block. This is a wood block, a softwood block, pine actually. I'm going to drop these 2 blocks into the water in the aquarium. One will sink, one will float. You probably have a prediction about what's going to happen. Let's find out. I suspect your prediction was correct, that the concrete block sinks. When I ask the question, why does the concrete block sink? The answer often is the concrete block is heavier than the wood block. We have to be careful with our vocabulary and understanding here. Consider a cruise ship. More buoyant force. This cruise ship behind me is in fact a huge hotel floating on the surface of the ocean. These huge ships can weigh over 50,000 tons. Despite this huge weight, cruise ships have no problem floating on the ocean. Whether an object sinks or floats is not determined by its weight, but by its density and the density of the fluid it is immersed in. Density is mass per unit volume. Back to our investigation of density and buoyant force, this table shows the wood is less dense than water and that the concrete is more dense than water. The wood block floated while the concrete sunk. A conclusion from this data is that objects denser than water will sink in water, while objects less dense than water will float on water. This is true for other fluids, not just water. This means that the cruise ship, even though it is extremely heavy, is less dense than salt water. This is because a large portion of the volume of the cruise ship is air. Sometimes an object neither sinks nor floats. We say it has neutral buoyancy. Fish can adjust their density to maintain a state of neutral buoyancy. They do this by inflating an internal bladder with air. This organ changes the volume of the fish without changing its mass, allowing it to match its density to the water it is swimming in. Scuba divers use a similar method with an external bladder to control their buoyancy. Human beings are very close to having a neutral buoyancy. The makeup of each individual determines whether they sink or float. We have demonstrated that density determines whether an object will sink or float, but we have not explained where the buoyant force comes from. When an object is placed in a fluid, it displaces or pushes out of the way some of the fluid. This displaced fluid pushes back on the object. This is buoyant force. All objects in a fluid experience buoyant force. Even the concrete block on the bottom of the aquarium is experiencing a buoyant force, but the force is not strong enough to lift the block. The Greek philosopher and scientist Archimedes is credited with figuring this out. The science behind buoyant force is known as Archimedes' principle. This principle states, The buoyant force on a submerged object is equal to the weight of the fluid that is displaced by the object. This means that the denser a floating object is, the more water it will displace. An object with a density of 0.5 grams per cubic centimeter will float only partly submerged, while an object with a density of 0.9 grams per cubic centimeter will float almost completely submerged.
The other ones are complete bullshit.
I hate to say this, but there's no such thing as the force of gravity.
What? I wish I didn't know that.